Hey folks, today we're going to talk about proving lines parallel. And I just like this. Okay, so we're going to prove lines parallel using the converses of the theorems that we talked about in the last lesson. So we can use angle pairs to prove that lines are parallel. If we know that we have corresponding angles congruent, then we can say that the two lines are parallel. So if you have two lines cut by a transversal that form corresponding angles that are congruent, then these lines are parallel. So let's take a try at this. Alright, so which lines are parallel if angle 1 is congruent to angle 2? So if angle 1 is congruent to angle 2, which lines are parallel? This would be our transversal. M would be our transversal, and then we got A and B making those two angles. So it looks like angle 1 and angle 2 congruent means that we would have corresponding angles here that would make A and B parallel to each other by the converse of the corresponding angles theorem. So let's see if you got it. Why don't you pause it and see if you got it. So if angles 6 and 7 are congruent, now this is our transversal, and L and M are going to be our parallel lines. So we can say L is parallel to M by the converse of the corresponding angles theorem. Booger buddies is your secret phrase for today. It's kind of fun. How do you become booger buddies with someone? That'll be your topic for discussion tomorrow. Okay, so more converses. Theorem 3.5. Put it in your notes. The converse of alternate interior angles theorem. If two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. So if you got two lines cut by a transversal and alternate interior angles are congruent, so if angle 4 is congruent to angle 6, then line L is parallel to line M. The converse of the same side interior angles postulate. If you have two lines cut by a transversal and you have same side interior angles that are supplementary, so the measure of angle 3 plus measure of angle 6 equals 180 degrees, then line L is parallel to line M. And then the converse of the alternate exterior angles theorem is basically if you have two lines cut by a transversal and you have a pair of alternate exterior angles congruent, then these two lines are parallel. So the converse of these theorems, the converses of all these theorems, take congruent angles and then prove that lines are parallel. Alright, so the proof of the converse of the alternate interior angles theorem below looks different from any proof you've seen so far. It's going to be new and different and amazing. You know two forms of proofs, the paragraph proof and the two-column proof. In a third one called a flow proof, arrows show the logical connections between the statements. It looks like a flow chart, sorta. Reasons are written below the statements. Alright, so here is a nice flow proof. Given that angle 4 is congruent to angle 6, prove that line L is parallel to line M. Okay, so angle 4 is congruent to angle 6. That we are given. We also know that angle 2 is congruent to angle 4 because vertical angles are congruent. Those two pieces of information come together to tell us, let's see what could they tell us? They could tell us that by the transitive property, if 2 is congruent to 4 and 4 is congruent to 6, they could tell us that 2 is congruent to 6. So angle 2 is congruent to angle 6 by the transitive property of congruence. Now, if you've got these two angles congruent, angle 2 and angle 6, those are corresponding angles. So if you have corresponding angles congruent, now we can use the converse of the corresponding angles theorem. L is parallel to M because if corresponding angles are congruent, then the lines are parallel. So that's kind of a fun way to write a proof. Neat. All right, let's write a flow proof for theorem 3.7. Okie dokie. So we are given that angle 1 is congruent to angle 7. What else do we know? We also know that angle 1 is congruent to angle 3 because they are corresponding angles. If we put those together, we get that angle 3 is congruent to angle 1 is congruent to angle 7, therefore by the transitive property, angle 3 is congruent to angle 7. Now we have corresponding angles. So we can use the converse of the corresponding angles theorem to conclude that line L is parallel to line M. Alright, so use the diagram up here to prove theorem 3.6. Okay, so theorem 3.6 was the same side interior converse. So if these two are supplementary, then the lines are parallel. So we will be given that they're supplementary, and then we have to prove that the lines are parallel. Okay, so we know that the measure of angle 3 plus the measure of angle 6 equals 180 degrees because that was given to us. We can also look up here and see that angle 6 and angle 7 form a linear pair. So I know that the measure of angle 6 plus the measure of angle 7 equals 180 degrees because they're a linear pair and those are supplementary. Okay, so now you kind of have your option here on what property you're going to use to put these together. You could say I'm going to use the transitive property, measure of angle 3 plus measure of angle 6 equals 180, and 180 equals that. Or you could say you're using the substitution property and you're just substituting this value in for that value. So either way you think about it, you're going to get measure of angle 3 plus measure of angle 6 equals measure of angle 6 plus measure of angle 7. Measure of angle 3 plus measure of angle 6 equals measure of angle 6 plus measure of angle 7. And that is by the transitive property. You could say it's by the substitution property too. Of equality. And now, since measure of angle 6 and measure of angle 6 are the same number, I can subtract measure of angle 6 from both sides of the equation. And that would give me measure of angle 3 equals measure of angle 7, using the subtraction property of equality. And then measure of angle 3 equals measure of angle 7 means that angle 3 is congruent to angle 7. And that's just the definition of congruent angles. They have the same measure. And then if 3 and 7 are congruent, then we have parallel lines because those are corresponding angles. So we can say now that L is parallel to M because if corresponding angles are congruent, then the lines are parallel. So my flow, I ran out of room and I had to kind of flow back this way, but Hopefully you were able to follow that. Alright, so determining whether lines are parallel. The fence gate at the right is made up of pieces of wood arranged in various directions. Suppose that angle 1 is congruent to angle 2. So here's angle 1, here's angle 2, and those are congruent. Are lines R and S parallel? So are these two parallel here? Yeah, they're parallel. Let's talk about why, though. Angle 1 and angle 2 are alternate exterior angles. If two lines are cut by a transversal and you get alternate exterior angles congruent, then the lines are parallel. That's just the converse of the alternate external angles, alternate exterior angles theorem. So, in problem 3, what's another way you could explain why R is parallel to S? Well, you could say that angle 3 is congruent to angle 2 by vertical angles theorem. And then 1 and 3 are corresponding angles, and they're congruent because we have, let's see, angle 1 was given congruent to angle 2. And then by the transitive property of congruence, you get angle 1 is congruent to angle 3. And then those are corresponding angles. So then you can say that R is parallel to S by the converse of corresponding angles theorem. Or you can say if corresponding angles are congruent, then the lines are parallel. And that's very neat handwriting. Alright, so geometry and algebra back together again. What is the value of x for which A is parallel to B? Well, if A is going to be parallel to B, that means that same side interior angles are supplementary. So we just need to find the value of x that makes these supplementary. So 2x plus 9 plus 11 has to equal 180. That's because of the definition of supplementary angles. So then 9 plus 111 is 120. Subtract 120 from both sides. You get 2x equals 60. Then you divide both sides by 2, and you get x equals 30. So, see if you got it. Can you do number 4? So for what value of w will C be parallel to D? Well, these are corresponding angles, so they should be congruent, which means that they should equal each other. So 3w minus 2 equals 55. Because corresponding angles need to be congruent. And then we add 2 to both sides. 3w is 57. Divide both sides by 3. W equals 19. So if W is 19, then C is parallel to D. Okay, we're done. Do some practice. Be awesome. Have fun. See you later.